In this tutorial, we'll cover some more core features of Slippery Chicken, including some layout features like title, staff groupings, and tempo map, as well as multiple sets in a set palette, multiple sections in set map and rhythm seek map, i.e. in the piece, and some output functionality like specifying the output file names and loading a file at the prompt to evaluate and produce output. So layout. One of the easiest things to specify is the title. This would put the title in the score and also create the names of the LilyPond files if you want to write LilyPond data files. The tempo map slot allows you to change tempo for the piece on a bar-by-bar basis. There's also a way of doing this with a tempo curve if you're interested. We won't look at this now, but you can check it out in the online manual if you like. The tempo map is very simple in that you specify the measure number followed by the beat basis paired with the beats per minute. The beat basis here is the rhythmic value that we're specifying the BPM for. If the tempo map isn't specified, it defaults to a quarter note of 60. Staff groupings allow you to group a number of staves in a score, for instance, the wind grouped together, the strings grouped together, percussion grouped together. And this is very simple as well. You simply specify in a list how many players you'd like in each group in the score, starting at the top and moving to the bottom of the ensemble. And of course, the sum of the numbers in that list must equal the number of players in the ensemble. This simple example shows you three of the features we've just discussed. First of all, the title, which is in this instance the string mini piece that will be reflected in the CMN score and the LilyPond score, as well as in the LilyPond file naming. You can also see that we've specified a tempo map, which is just one tempo for the whole piece, starting at bar 1 with a quarter note of 84. And we've also got staff groupings broken up into 2 and 3. So that would be the flute and the clarinet, the two wind instruments grouped in a pair, and the trio of string instruments below them. We then got the usual calls to MIDI play, CMN display, and write LP data for all to generate the output files. Moving on to multiple sets in the set palette. IDs for sets and rhythm sequences are generally numbers or symbols, but they could, of course, be strings as well if you wanted to. The most important thing to note is they can be exactly what you want to. They can be something that can remind you of which set or which rhythm sequence we're dealing with, or it could be something more abstract. It's completely up to you. You can have them in any order in the palettes, but of course they have to be placed in the desired order in which they occur in the set map. And the number of sets in the set map must equal the number of rhythm sequences in the rhythm sequence map, because it's a core feature of Slippery Chicken, or a core requirement of Slippery Chicken, that there is one set per rhythm sequence in the piece. So this very simple example shows the title as we've seen before, but also 3 sets in our set palette. The first set is identified by the number 1, but the following 2 sets are identified by the user chosen symbols seek2 and dominant, and these then appear in the set map. Section 1, first of all set 1, then the set identified by seek2, then the set identified by the symbol dominant. That's 3 altogether, so that means that we've got to have 3 rhythm sequences in our rhythm seek map as well. We can have as many sections or subsections in a Slippery Chicken piece as well. For instance, in this piece, we can see that there is going to be 3 sections. You can see that straight away in the set map here, 1, 2, and 3. These do have to be numbered sequentially ascending. They have to be numbered sections. They can't be symbol named sections at this point, and that's for reasons which we won't go into now, but they're important for change maps, which are a sort of underlying category or class within Slippery Chicken. This 3-section piece is also identifiable in the rhythm seek map. You can see in the rhythm seek map we have section 1, section 2, and section 3. And of course, this is a little bit more complicated than the set map. The set map applies one set per rhythm sequence, but that set applies to all of the players or instruments playing at that point. But when it comes to the rhythm seek map, we can have, of course, one instrument playing one rhythm sequence and another instrument playing another separate, different rhythm sequence. So they have to be specified once per player. So you can see in section 1 we've got CL, VN and VC referring to our clarinet, violin and cello players in our ensemble. And they just play the 4 rhythm sequences 1, 1, 1, 1. And of course that means there's got to be 4 rhythm sequences matched by 4 sets in the set map. And you can see that in the set map in section 1, tonic, dominant, tonic, dominant. Now, there's no restriction that then the second section, or indeed a subsection, has to have 4 rhythm sequences and 4 sets. They can have as many as they want to have, as long as in each section or subsection there's exactly the same number of rhythm sequences and sets. Up to now, we haven't been specifying the output files for MIDI play and CMN display to write. They've all been written to the default location, which is in the /tmp folder. You can, of course, specify the file name which you would like to write. In MIDI file writing, that's specified with the MIDI file keyword argument to MIDI play, and in CMN with the file argument. In LilyPond, you specify a base path. This will be the directory in which the LilyPond files will be written. This is slightly different because LilyPond files are numerous, 1 per player, plus another extra 1 per player to create the actual part as well. So this next example shows how you can create a Slippery Chicken structure and then call those 3 main output methods specifying the file which we would like to write. One other thing to note about interacting with a Lisp interpreter is that it's possible to just copy and paste or even type the Lisp code into the interpreter and have it evaluated there and then. Or, and this is more likely in the development of Slippery Chicken pieces, you can write the code into a file and load it into a buffer. This makes it easier to generate longer pieces with more complex code where it's an incremental process of slowly editing and extending a larger file and loading it each time without having to copy paste or indeed type.